Hello guys, today we are going to discuss the topic of WRC Beam of the subject Elementary Structural Design 6M Civil Engineering. Myself Assistant Professor Gaurang Prajapati from Civil Department MGTer Navsari. First of all, we should understand the basic concept of the WRC beam. For that one, first we need to understand why we need to provide the WRC beam. So, when the applied moment on the beam is more than the moment of resistance of the beam, the structural designer has three options. Number one, to increase the depth of the beam. Second, to use higher grade of concrete to improve MR. MR means moment of resistance. And the third, to provide the reinforcement in the compression zone of the beam to increase its MR. Now, talking about all these three options first, when we increase its depth of the beam, so ultimately what will become, if the depth is increased, the headway, that is the distance from the floor to the beam, will be reduced. So floor height will be comparatively reduced, particularly in the beam portion. Talking about the second option, when we increase the grade of the concrete, ultimately cost of the beam will also be increased, so that is also not that much good. So in these circumstances, the usually designer choose the third option, that is provide extra reinforcement in the compression zone. So ultimately that will become the WRC beam. So talking about the definition of WRC beam, as we have already discussed above, when the applied moment of the beam is more than the moment of resistance of WRC beam, the moment of resistance of the beam is increased by providing the reinforcement in the compression zone. This type of beam is called the WRC beam. Now, moving further, the next slide. The necessity of WRC beam means why we need to provide the WRC beam. Usually, WRC beam provided in following the circumstances. Say first one, when it is not possible to increase the depth of the beam due to the architectural purpose. Second, to get the more headway in the room, that we already discussed in the previous slide. Third, when the beam is subjected to a reversal of stresses, means in case of the earthquake. Usually reversible of stresses usually occur during the earthquakes. For precast beam, then when the loads are eccentric, that means not acting at the center, that is we can say axial load. Next, when the beam is subjected to accidental or sudden lateral loads. And last, in case of the continuous beams or slab, the sections at the supports are generally designed as WRC beam. So these were the requirements, or we can say necessity of the WRC beam. Now, stress diagram for WRC. Now, before understanding the concept of stress strain diagram, first of all, we need to understand the basic concept of WRC beam, means how WRC beam is made. Now, we can see in the figure number 4.1, that is WRC beam section. Usually, WRC beam is the combination of single RC beam as well as auxiliary section. As we can see over here, this one is singly RC balance section, that is typical single RC beam. Now once we add extra reinforcement in this beam, ultimately it will become the WRC beam. As we can see, the extra reinforcement means I am talking about this extra auxiliary RC section, means imaginary beam. Now as we can notice, in case of single RC balance section, only reinforcement is provided in the tension zone, that is denoted by AST1, we can see over here. Now in case of the auxiliary section, tension reinforcement is again then in the tension zone, that is AST2, but what different is compression reinforcement is provided in the compression zone, that is ASC. So once we combine these two beams, ultimately it will become our WRC beam. Now as we can notice over here, the AST is there. Now this AST is the combination of AST1 plus AST2, that is total tension reinforcement of the WRC beam, while this ASC indicates the compression reinforcement in the compression zone, that is come over here. Okay. So ultimately in case of WRC beam, both the reinforcement will be there, say compression reinforcement and tension reinforcement, and both the reinforcement will carry the load for that one. Now as two reinforcements are provided, so two covers will be also required. So in the tension reinforcement over here, the tension reinforcement cover, that is denoted by small e, and the compression reinforcement cover, that is denoted by small d dash, that is shown over here in the figure. Okay, now we should further move on the concept of the straight strain diagram. Now in the previous lecture, in case of singly RC beam, we had already discussed the stress and strain diagram concept of the singly RC beam. Over here we can notice that the singly RC beam strain diagram and singly RC beam stress diagram is exactly same as we had discussed earlier in case of singly RC beam. As doubly RC beam is the combination of singly RC beam plus auxiliary section, so ultimately all the stress and strain diagram concept of the singly RC beam will be the same over here. There is no difference in that one, but what will change, that is the auxiliary section stress diagram, that is over here. Now we can notice that compression force and tension force as the same as case of singly RC beam are acting over here. Now in addition, compression force and tension force will also be acting over here in case of auxiliary section. Now we can see over here C2 force is acting at the distance of D dash from the top, and T2 force is acting at the bottom, usually at the tension reinforcement. Now the extra lever arm will also be generated in this case, that is denoted by Z2. Now if you want to calculate its formula, it is simple. This one is D minus D dash, so ultimately we will get Z2. So this is the basic concept of the stress strain diagram of doubly RC beam. Now, which we already discussed in the figure, notations of the diagram: B, that is width of beam; small d, that is effective depth of beam; capital D, that is overall depth; XU, depth of neutral axis; E, that is effective cover to tension reinforcement; D dash, effective cover to compression reinforcement; AST1, that is this one over here, area of tension reinforcement required for the balanced singly RC beam; AST2, that is the case of auxiliary section, that is area of the additional tension reinforcement; and AST, that is of the main WRC section, area of the tension reinforcement for WRC beam; ASC, that is area of the compression reinforcement; FSC, stress in compression reinforcement; FCC, compressive stress in the concrete at the level of the compression steel; FCK, compressive strength of concrete; and FY, yield strength of steel. Everything parameters that has concern about this figure we had already discussed. Now two new terms have been come, that is FSC and FCC, that will be discussed in the further slides. First of all, let's understand the concept of formula for the singly balanced RC beam and auxiliary section. Talking about singly RC beam, all the forces were same as case of the previous lecture, that is of singly RC beam. C1, that is force of compression in concrete, 0.36 FCK BXU; T1, force of tension in the steel, 0.87 FY AST; Z1, lever arm of the singly RC beam, D minus 0.42 XU. Now these all formulas were the same case of this one. Say this, we are discussing about this one, that is the balanced singly RC beam stress diagram. Now we should concentrate on this diagram for the formula of C2, T2 and Z2. For that one, C2, force of compression in compression reinforcement, that is FSC minus FCC into ASC; T2, force of tension in additional tension reinforcement, that is 0.87 FY AST2; and Z2, that is lever arm for the auxiliary section, D minus D dash. Now further moving, as we already said in the previous slide, we should understand the concept of FSC and FCC. So first of all, let's start with FCC. FCC equals to compression stress in the concrete at the level of compression steel. So for up to D dash by D ratio, that is equals to 0.20, FSC is usually taken as 0.446 FCK. And talking about FSC, stress in the compression reinforcement, for MS bar, say for plain bar, for the grade of FE 250, FSC is taken as 0.87 F5. And for HYSD bar, HYSD means high yield strength deformed bars, FSC is obtained from the following table, that is given in SP 16, table F, page number 13. Now as we can see in the table, the value of FSC is different for the different D dash by D ratios for the different grades. For example, if D dash by D ratio is 0.05, then for FE 415, FSC's value is 355. If it is 0.10, then it is 353. If the ratio is 0.15, FSC is 342, and if ratio is 0.20, the value of FSC is 329. For example, if ratio comes 0.08, then we should consider the higher value, not the lower. Say for example, if the ratio is 0.08, then we should consider the value of 0.10. Similarly, for the grade of FE 500, the different value of FSC as per the different d dash by d ratios are also there. Hope you guys are getting my concept of d dash by d ratios and the value of FSC. Now, the basic difference between single RC beam and doubly RC beam. So first of all, the cross section is different, as we can already understand the basic content of single RC beam. Only one reinforcement is there in the bottom zone, means tension zone, while in case of doubly RC beam, two reinforcement will be there. Okay. Now second, in case of single RC beam, in tension zone, tension reinforcement is provided, while in case of doubly RC beam, in tension zone, tension reinforcement is there, but at the same time in compression zone, compression reinforcement is also there. Third, in case of single RC beam, in compression zone, two numbers of 10 mm dia anchor bars are provided. The anchor bars are not designed to carry any compressive force. See, we had already discussed compression force is not required in case of single RC beam, but we need to provide two anchor bars to support the stirrups which is provided in the beam for the shear reinforcement. While in case of doubly RC beam, in compression zone, compression reinforcement is provided which will resist the compression force because it is requirement criteria. Fourth, when mu is less than mu limit, beam is designed as single RC beam, while if mu is greater than mu limit, the beam is designed as doubly RC beam. Fifth one, if its moment of resistance of the single RC beam is less, while in case of doubly RC beam, MR is higher. In case of single RC beam, its ductility is less, while in case of doubly RC beam, its ductility is higher. 7. It is not suitable where there are chances of reversal of stresses, means in case of the earthquake, single RC beam is not that much preferable, while in case of doubly RC beam, it is quite much preferable during the reversible of stresses. So guys, hope you got all the concept of the doubly RC beam. Okay, thank you.